Welcome back to another episode of the Cyber Distortion Podcast. Today, Kevin and Jason are chatting with Dr. Gregory Carpenter. Dr. Carpenter is a fixture in the cybersecurity community and a distinguished cybersecurity expert. With over 27 years of service as a U.S. Army officer, he has held various senior military and civilian positions, including Vice President for Cyber Operations, Chief of Security Testing, Counterintelligence Division Chief, and Chief of Special Space Operations. An accomplished author, Dr. Carpenter co-authored the book entitled Reverse Deception, Organized Cyber Threat Counter-Exploitation, which delves into counterintelligence tactics to combat cyber espionage. This episode, entitled Human IoT, Submolecular DNA Cybersecurity, is one that we know is going to blow your minds. Enjoy the show.
Welcome, everyone, to the Cyber Distortion Podcast. We have another interesting episode for you tonight. So we're trying to change it up a little bit again this season, and bring on different topics that we haven't dove deep enough into or have just scratched the surface on in the past. And tonight, we're going to be talking about the human element. Really, all of those aspects around the challenging parts of the mental fatigue that cybersecurity practitioners have to deal with, or, anyone who is dealing with their regular workload on a daily basis. And we're going to go deeper into that, into some extreme aspects of the mental and physical elements of the human body. And tonight, we have a great guest to bring and deliver this information to you all tonight with us. We have Dr. Gregory Carpenter. We're so excited to have this guy on because I've listened to some of his work and I've looked at some of his presentations, and he will get into the deep and dirty science behind how some of this stuff works. He'll also open your minds to some things that you haven't thought about before. So I'm super excited to dive into this with Kevin tonight, and we're going to see where this goes. So Kevin, I'll hand it over to you.
Yeah, absolutely, man. Thank you, Jason. I want to give before we even get started, I want to give a very special thank you to our good buddy Lynn No over at the Cyber Cognition podcast. Lynn is a good friend of ours. He's part of our Cyber Circus network, and he is actually responsible for introducing us with Dr. Gregory Carpenter tonight. So thank you, Lynn, for that. And yes, I encourage our listeners to go check out their podcast, Cyber Cognition Podcast. They talk about everything around the world of AI, and some of that stuff is so fascinating and intriguing. I know you'll love their podcast as well. So before we get into the meat of this, Dr. Carpenter, I would just like to read your bio because it is quite impressive. So I'll start at the top here. Dr. Gregory Carpenter is the principal partner of CW PinSec. He holds the title of Fellow of the Royal Society for the Arts in London, and was named the National Security Agency's Operations Officer of the Year. He is co-author of Reverse Deception and an advisor for Red Seer Security, a senior advisor for ARIC Inc., and a Special Operations Medical Association member. Dr. Carpenter has also served on the International Board of Advisors for the McKinsey Institute and as an advisor for EC Council University. Already impressive, and I'm not even halfway done. Prior to your current role, you held various senior military and civilian positions, including Chief Security Officer, Vice President for Cyber Operations, Chief of Security Testing, Chief Operations Officer, Counterintelligence Division Chief, Chief of Special Space Operations, and Functional Team Lead for Electronic Warfare. You are a retired officer who served 27 years in the U.S. Army, holding a Bachelor of Science and a Master of Science and a doctorate in public health. Wow. Your professional certifications include Certified Information Security Manager, Lean Six Sigma Black Belt, and ISO 9000 Lead Auditor. And to all of this, I'm just going to say two things. Oh my God, that's some credentials right there. And thank you for your 27 years of service in the military. And I'm just honored that you decided to come on with us tonight. Thank you, Dr. Carpenter, for joining us.
I just don't know how you fit all of that stuff in a lifetime.
I know.
It's just so much.
I know. You're too,
and again, yeah, thank you for your service. I do appreciate everything.
Dude, you're too young to have that many credentials. I don't know.
Right,
Would you start
right.
at 5 years old or what?
Well, it comes down to the needs of the Army. When the Army says you're going to change positions, you're going to go from one functional area to another function area, you do that.
Yeah. Yeah.
I have to admit, my favorite was Chief of Special Space Operations, because I don't get to tell anybody what that's about. So,
okay.
Yeah.
Okay.
That was a pretty good one.
Nice.
Well, we're super excited to have you on and get into the meat of this stuff. I think, like, let's kind of start at the highest level and work our way down. So let's start with this conversation around work-life balance and the impact that it has on cybersecurity practitioners and the stress that it brings. We all know how much stress it brings. You know, if you've ever been, from a cyber standpoint, if you've ever been in the middle of the battle trying to mitigate an issue before it explodes into something even worse than what it already has, and put your arms around it and get controls in place so that you can get things back online and not turn into something really bad. That can be an extremely stressful event. I've had employees tell me that after fighting a cyber event, a seismic cyber event, many months later, that they still had forms of PTSD, thinking about the next issue being another big issue like that, because they put so many hours in and efforts, continuous hours of work into trying to fight and mitigate and resolve these issues, and not really knowing where it comes from or what the next issue is going to be or how to resolve it or what the next challenge is going to be until you get all the way through it and you've worked your plan. And maybe you've worked your plan and you still have problems, right? And you have to kind of think on the spot. That uncertainty has caused them to really feel a lot of stress and be very uncomfortable. And I know a lot of you out there probably know exactly what I'm talking about there. But let me walk through a few stats. The British Interactive Media Association recently revealed that tech workers are 5 times more likely to suffer from mental health problems than the wider population. Whoa, man, I believe that one.
Mm-hmm.
You know, just managing mental health sometimes it's a big deal. But I got to tell you some other things that go along with it. So Nominet's latest CISO stress report has also revealed that almost 9 in 10, so 88% of chief information security officers consider themselves under moderate to high stress levels. That the same report revealed that CISOs lose on average $35,000 a year in unpaid overtime, while increased stress levels have resulted in a 26-month tenure on average. These findings underscore the significant strain on CISOs and their well-being. Now, that $35,000 a year, dude, I could tell you, I put in so many extra hours working issues, nights, sleepless nights, working shifts that go for, 3 days, without sleep. Those things are detrimental to your health. Doesn't matter how you do it. If you're not sleeping for 3 days and you're under high stress, it's detrimental for your health. So these are the conditions that people are working under. No wonder 26-month tenure is what the average, tenure is for a CISO. There are challenges associated with that. And it starts to come around the thinking of, how do we provide better support to help technology professionals manage their mental health better and stress better? I think that's kind of where I want to start tonight, is diving into that conversation a little bit. So, Dr. Carpenter, what are your thoughts?
Well, does any of that really surprise you to start off with?
No,
right?
No,
not at all.
Yeah, we've all been there. We've all lived that, going 3 nights straight of working through the night with one other guy sitting there trying to figure out, how we're going to complete this incident response and make something happen. So the customer is going to be happy, right? So we don't destroy everything.
Yeah.
But I would say that what you've cited there actually is consistent with a growing body of empirical research. The findings that you were talking about, we already know from occupational health psychology, behavioral economics, and cyber leadership studies that this is exactly what happens when people are under stress for very long times. Cyber leadership is increasingly become compared to a crisis management role. The CISO specifically, constant high alert operations. You're on all the time. Asymmetric threat environment. And what do you have? At the core of that, you have a blame-centric culture.
Oh, yeah.
Right? That finger comes right to the CISO, not anywhere else. So chronic stress amongst CISOs, yeah, it's predictable. Absolutely. So I think there's several things here that we could highlight as we talk about it. The first thing that I think is probably the most important is the role of a CISO. The expectations of a CISO are not, I'll say they're misaligned with human capability and human limitation. And there could be a lot in there to pack in there, but very simply, there's quite a bit of research that shows that cybersecurity operations, as we know, are 24/7, 365. It's a cognitive threat environment with no decompression window. You have no chance to take a break. You're not catching your breath anywhere. It's an always on, it's never off expectations. It creates hypervigilance where you're always on edge. You're high alert all the time. And that leads to emotional exhaustion. You really have decision fatigue. You can't make decisions. You have burnout. And it's a pattern that's been documented over the years. CISOs are just the latest group to be identified with this group of people. And the people that we're talking about, mostly military, police officers, healthcare workers in an emergency department. These folks are always going like this all the time. Same thing as CISO has to do all the time. You're on call 24/7, right? No good. I'd say the second thing that's pretty important is the accountability is it's going up faster than the authority that's associated with it, right? You said there's going to be a huge shift, corporate shift, where CISOs are going to be more responsible. It's moving away from private sectors, insurance companies being responsible for what's going on. CISOs are going to be taking on a lot of this responsibility if something happens, when an incident happens. And the CISO is going to be in a position to produce. They're going to have to perform, and they're going to have this many resources, and they're going to have this much authority. Way, way, way down there. It's not a board position. Should it be a board position? Maybe so, because of what's demanded. I can't think of a CEO that would not hesitate to fire a CISO in a second, even if he thought that the CISO had done any one thing, that he didn't think was correct, regardless of if he did everything he needed to or not.
The interesting thing with that too, those two combinations of what you said in the first one and the second one, what it reminded me of being in that situation. It reminded me of having all of that responsibility and weight on your shoulders and being able to manage that. But the breaking point is when the entire organization is looking at you and dependent upon you and coming to you because they don't know what else to do. And the only answers and the only way through it is whatever you're going to come up with to help them get through it. That's it. It's on you. You figure it out. You have to tell them how they're going to make it through, or they're not making it through.
And that's the amazing thing is that they'll look to you for that guidance to do that, and then they'll fire you.
Yeah.
Yes. Yes.
As soon as you get the systems back online. Yeah, right. They're looking at you to see how prepared were you for a situation like this that's gone full-blown panic mode, disaster state. Now we're into recovery situations. And yeah, I mean, knowing that much weight's on your shoulders, it does. It classifies the CISO right up there with emergency responders, first responders, air traffic controllers. They say they have a very stressful job. I don't know any, but I can't imagine that that's not stressful. And yeah, the technology today enables us to be more prepared than ever and more in the know than ever, which is a blessing and a curse.
Yeah.
Because we can't ignore an alert. If I'm laying my head on my pillow at night and I do one last check of my phone before I go to sleep, and I see that an alert came in and it may or may not be critical, what do you think I'm going to do, guys? You think I'm going to roll right over and go to sleep?
You're going to go for that.
Yeah.
You're going to check it out.
Yeah. I mean, and that happens quite often, to be honest. And you're in a movie.
Yeah.
You see your phone light up.
Yeah.
What's your instinct? Can you enjoy the movie without looking at the phone to see if it's a disaster going on at work? Not really.
Yeah.
Blessing and a curse, I'm telling you.
Conditioned
Yeah.
responses. Yeah.
Well,
Yep.
There's a lot to that, and that's kind of the mental aspect of what we're talking about. But there's also the physical aspect, which we should talk about as well. I mean, we work in desk jobs for the most part. And even if you take the most healthy approach to working in a desk job, let's say you've got an elevated desk so that you stand all day, you're still very immobile. It's a non-physical job. Desk jobs, we've been told all our lives, the less movement you get, the worse it is for your body. It's detrimental to our health. Yeah, of course, we're not as likely to get hurt on the job through something physical. We're not going to strain our neck or break our back or cut off a finger, most likely ever, in a computer-based desktop type job. But the reality
I've been
is
in some server racks that my finger could have come right off on your back there.
Yeah, I've actually
I've
worked at a few of those myself, and actually some of those old DL360s used to be pretty damn heavy, man. If you could smash a finger.
That's what I'm thinking about.
I remember those days. Yeah, those old 6U servers that weighed about 200 pounds. Those are great. But I want to read to you guys some of the known byproducts of having jobs like this, and we'll talk about this, but inactivity and prolonged sitting leads to, and this is proven, increased risk of chronic diseases. So studies are showing that the more you sit, the more it's linked to obesity, obviously. type 2 diabetes, heart disease, certain cancers from being inactive, metabolic decline. It can slow your metabolism down, affecting your blood sugar regulation and fat metabolism. And then, of course, there's the musculoskeletal issues.
You got it.
That was hard. Poor posture, lack of movement, back pain, neck pain, other issues like that. So knowing this, if a desk job typically is going to pay better, let's just assume that it pays very well in most IT positions. It can be fruitful, less demanding physically on your body, but the inactivity can lead to other types of, inactivity related diseases and stressors on your body. So Dr. Carpenter, how do we balance all that? What do we make of that?
Let's start with the truth, as you mentioned it. Your body's built for movement. It's not built to be a static display for your trophy wife. Okay. That's not what you're supposed to be doing. Prolonged sitting. Yes. Task focused screen work, consuming blue light all day in every single device that you have. It's terrible. It creates low grade stress, triggers neuroendocrine cascades, which is terrible. It deregulates different systems in your body, your metabolic system, cardiovascular, musculoskeletal. Did I get it?
Yeah, you got it. Perfect.
Yeah, and even immunological, right?
It's almost like you've said that.
I said it once before. So, but to go a little bit deeper into what you're talking about, you've highlighted some extremely important issues here. There's some recent research that I was using for some of my other work that shows that sitting for more than just 6 hours a day is associated with 19% higher risk of mortality.
Wow. Oof. Wow.
That is amazing. And every additional hour of sitting over 5 hours increases cardiovascular disease risk by 12%.
Oh my gosh.
So does it help if you get up and move for 3 minutes and then sit again? Or I mean,
so that good question. Good question, because you have it. I'll answer it in a second. Absolutely. Office workers show reduced muscle firing. That is neurological activity to stimulate muscle movement, circulation, lymph flow. Your body is basically sitting there in a muck, like you're in a swamp. Creates inflammation. It's horrible. So to answer your question, the answer goes beyond like a standing desk or ergonomically correct chair. You have to repattern the workplace, repattern your workflow per se with ultradian systems.
Mm-hmm.
Now, all right, Greg, what in God's name is an ultradian system? Well, you know what? Basically, you have ultradian systems, you have circadian systems, and you have infradian systems. An ultradian system is something that happens all the time in your body, very frequently. It's a closed system, blood flow, ultradian system. Heartbeat happens more than every 24 hours. Circadian system happens once every 24 hours. Infradian system is something that happens over 24 hours. So like a menstrual cycle, for example. Okay. That's an infradian system. So when you break up the ultradian system cycles, these small cycles from what they normally do by sitting all day, you actually break down your metabolic function in your body, and you're creating mental fog for yourself. Micro movements are great. Every 30 seconds, 1 to 2 minute body activation, things like that stimulate blood flow, will help you be more aware, be more engaged. Different types of we like to do something in our office where we do walk to voice notes. If you're taking your notes and you're doing audio notes into we dictate a lot in the medical field, right? So you walk around and you dictate instead of just sitting and dictating. We have walking meetings. Those are the best. Just if you have two people meeting or something. remember the key for ultradian systems is that your body works best in a 90-minute cycle. So the 8-hour workday of you sitting down for 8 hours is, throw that out the window. That's what we call a bad idea. It doesn't work well. It works great when you're writing labor laws or things like that, because if you have your own business, you don't pay attention to that 8 hours anyway. And what happens is you plop down and you work and you do what you have to do. So there's the issue of the 90-minute window. Set a timer, get yourself up, go out, go for a walk, do something. Don't just sit there. It's not only improves physical health, but it also increases the neuroplasticity, creative cognizance, your ability to make decisions, to solve problems. You have to rethink fitness as cognitive hygiene instead of something that you do on the side. It has to be incorporated into the maintenance of what you do every day and who you are. So I think that the way we look at how we treat ourselves in the office has a lot to do with that. You can break down a lot of the stress that somebody feels just by going out and taking a 2-minute walk. Just by, you take a bathroom break and you come back and you're like, where was I? Okay, I can think again. Yeah. And it's not because you had to do like a download of something. Okay. That's not part of the process, but the time that you took and you went and you walked wherever you went to and came back, you made the blood flow enough again so that this thing started working, because it was lacking blood and it couldn't work well. You're working in a mind fog.
So Dr. Carpenter, based on what you just said, would it make a lot of sense for anybody that has a desk job then to plan a 5-minute break every hour and a half throughout the day to just get up and move, regardless of what you're doing, just get up and move?
Sure. I would say even more often than that, a lot of research shows that you actually can re-stimulate your body more vigorously at about a 20-minute mark.
20 minutes.
So if you do that just at the 20-minute mark, just get up, stretch your legs, walk around. Just a couple of minutes worth is really all it takes. You're actually you're not only breaking yourself out of the physical lockdown that you have, but also the mental and the emotional lockdown that you have, because we've all seen people sit at the computer and they're like this. By the midday, they're like this.
Yeah.
Right? Emotionally, they're drained. They can't do anything. It's we call it an emotional bottleneck. That's what the sedentary body does. And prolonged sitting, it suppresses the vagal zone, which is controlled by the vagal nerve, which you measure with a good heart rate, right? Parasympathetic nerves. All of this is extremely important to make sure that you have good blood flow in your body. The vagal nerve controls the liver, the digestive tract, immune regulation, gastrointestinal sensitivity, inflammation. You really need to have that blood flowing, and you need to stimulate it. And the longer you sit, the more the vagal zone is suppressed and is not able to actually address the things that your body needs to have addressed so that you are going to be healthy. The longer you sit, the worse you get, and you make poorer decisions because you're emotionally distracted and you are physically in a fog. So you, in no way are you able to make a good decision. So you have a CISO who's like this and sitting at a keyboard like this, and now I have an incident. And this poor guy's got to try to figure out exactly how to do something, and literally has to wake up to be able to respond according to his emergency response plan. Even something simple like that, can't follow it because he can't think.
I tell you, man, you guys got me thinking tonight that I was just telling Dr. Carpenter that I spent the last 3 months writing code, and now I'm sitting here thinking in my head, my logical mind is running together a lot of different scenarios. And one of the scenarios it's running is, in our last episode, was talking about the number of hours that we spent in our lifetime doing certain things.
Mm-hmm.
Can you imagine the number of hours that a person has been a programmer or a CISO or it's a technical person has spent sitting in a chair?
Yeah.
And all of those symptoms that
Sure.
he was just talking about are all things that your body was put through and continues to be put through as
Mhm.
we do this stuff to ourselves.
Yeah.
And even knowing that, it is still hard for me to make myself get up and move. Although I don't do it enough. And although I do know that I've had success when I can take a break and go on a walk and come back. And guess what? I figured that problem out while I was walking somewhere because my mind just got
reactivates.
released. Yeah.
Yeah, you
Yeah.
reactivate. And it's interesting. And one of the other important aspects of sitting on butt all day is that you really need to ensure that you have plenty of water.
Mm.
You realize in your lifetime that do you think you drink more water in your life or you use more water washing your dishes in your life?
Oh, I think we use more water doing other things than drinking it.
Absolutely. So 165 times more water is used by you showering in your life than drinking water.
I believe it.
Over 7,000 times more water is used to wash your dishes.
Wow.
Than you drink. And odds are your average person only drinks about 40% of the water that they need in their lifetime.
Wow.
Yeah, I believe that. I'm not a huge stick to my guns when it comes to drinking the amount of water that I know I need to drink every day. And for me, I always leave the house and say, okay, at the very least, by the time I get home from work, I want to have drank 64 ounces of water, for example. Usually when I get home, I look at my bottle and it's at about 30 ounces. And so I haven't even cleared out the first bottle and I'm home driving home from work. And I get so mad at myself because that's something that's so easy to control. But I think
you've created a recursive loop.
Yeah, exactly.
You're stuck in.
Exactly.
And you get angry at yourself because you didn't finish the water in the first place.
Yeah.
If you gamify it, you might have a better chance of finishing all the water.
Buy a bottle that's got, something encouraging at every 2 or 3 ounces so that you can enjoy it at least. Yeah, I'm really bad about that one. I've got water here tonight. I don't have a beer. I don't have a cocktail. I don't have a glass of wine. I'm drinking water. I'm being a good guy.
I've got them both. I got them both.
Oh, you got both?
Good call. Yeah, I left the scotch in the other room today. I don't know what I was thinking.
Yeah, well.
All right. Well, hey guys, we went through some good stuff, but I think it's time for us to get deeper.
Yeah.
Let's take a quick break and let's come back and let's dive a little deeper into the brain of Dr. Carpenter.
Sounds good.
Alacronet is a value-added reseller that provides cybersecurity-specific security solutions, services, and staffing. We are an agnostic security partner, which allows us to present multiple options for each security need. Our catalog of services encompasses a range of security solutions, penetration tests, and staffing options. With our approach, we can bring the best options and price points forward to increase your security posture and prevent vulnerabilities. Alacronet is constantly adding new partners to meet the challenges of an ever-changing security landscape. As security experts, we know how to find security talent. Our entire organization is focused on cybersecurity, from leadership to sales team to technical staff and hiring staff. For more information on our vast list of solutions or services, please give us a call or visit our website at www.alacronet.com. We look forward to growing with your business.
Welcome back, everybody. We're in the middle of a fascinating conversation with Dr. Gregory Carpenter, and we're talking about all things impacting the human. We just went through a deep conversation around the emotional and physical aspects of the tech worker, the infosec worker, the challenges and the stress that are applied on you and throughout your lifetime through some of the things that you do on a daily basis, like just sitting. And it just really has got me thinking, I got to get myself moving again, Kevin. I'm just not moving enough.
I'm going to start doing jumping jacks every 20 minutes, man. I'm not going to drop dead of a heart attack. I'm not going to let that happen.
I am going to get there again. Now we're going to go a little deeper. And when I say a little deeper, there's multiple dimensions in how far we can go with Dr. Gregory Carpenter. Let me tell you, we're just starting to go a little bit deeper into this dimension. So hopefully we won't lose you in this one, but it will be fascinating. So, Dr. Carpenter, I've heard you refer to yourself as being involved in cybersecurity at a more finite level. And in particular, I'm going to quote this. This is a quote. So the quote is, research implementing InfoSec at the submolecular level through different innovations like blockchain. So tell me about that. What does that really mean? We're talking about blockchain and submolecular levels, and where are we going with this?
All right. Well, yeah, absolutely. I'd love to shed some light onto this. So what we're saying when I work at cybersecurity at the submolecular level, it refers to the set of advanced research domains that I engage, and they go well beyond traditional digital security. Most people think of cybersecurity, as firewalls, implementing controls, patch server maintenance, password policies. That's important stuff, but we're forgetting that humans are machines. And that's kind of where I'm focused. So my work in what we call submolecular InfoSec is a small group of professionals. I think there's about 30 people that I know around the world that are working in this area right now. And that just means applying information security principles to biological, biochemical, and even quantum level systems. So let me answer it like this. What is submolecular InfoSec, right? At its core, it's protecting information wherever it exists, even if that information is encoded not on a hard drive, but in DNA or proteins or cellular interactions. We're living in a world where biological and digital entities are merged. Biosensors, neurointerfaces, medical IoT, synthetic biology, DNA computing. All of these generate, process, and transmit information. That information can be intercepted, altered, and destroyed, just like in any other IT system or cyber system. So consider someone doing a cut and paste on your DNA, and the next thing you know, your hair turns gray or worse. So I kind of explore how we secure these processes, often in systems as small as single molecules or a biological signal. So take medical device security, right? We'd look at that at the nano level. That's 10 to the negative ninth. That's what we call small comparatively to, me having a hamburger or something like that. Hamburger's this big, nano is smaller than that, right?
Yeah.
But for ensuring that, an insulin pump or brain computer interface or cardiac implants are secure or tamper-proof is one thing. Taking a nanoparticle that you put in your body, either through injection or you aspirate, you breathe it in, and it will digitally go to where it needs to go in your body. Basically, you create like a web around your heart, and those are cardiac sensors. Well, they're hooked up to a system in the back end because they can't operate on their own. And what are they hooked up to? They're hooked up to Billy Bob running Windows 95, right? Not good. So it's things like that are extremely concerning to me, that made me get into that aspect. And then if you want to consider biocybernetic authentication. God, what's that, Greg? I'm glad you asked. Instead of like having a password or a fingerprint, something like that, imagine using like your real-time blood chemistry or neural response patterns to authenticate access into a system. It's not what we're doing right now, but that is, I would say, next generation at not one deviation away, but like 0.25 away. It's extremely close. DNA and bioinformatics protection. In synthetic biology, you program DNA like code. And I think we're working on some good ways to encrypt and watermark genetic sequences. If you can imagine doing that across the chromosomes, you've watermarked it, right? Like you would a Microsoft Word document.
What are the
You can
implications
prevent
of that?
terrorism and what's that?
What are the implications of that? Like the physical implications of that, of like adding something like a watermark?
None at all.
Hmm.
The tests that we've run so far show that it's superficial to the process itself, because we're not using the same nucleotide bases, which are the key components inside the chromosomes themselves. As long as you don't change those, you can run something through that. It'd be much like taking this card and actually putting a piece of tape over the top of it and then melting the tape on. You can't get it off, basically. It's going to take you a lot to get it off, but it doesn't hamper the function of the card, because the card doesn't function that way. It
But it
functions
still
a different
alters
way.
the card, right?
What's that?
It still alters the
yeah.
card.
Yeah, but it doesn't impair the function.
Yeah.
I still have the chip.
Yeah. But when I stick the card in my pocket and the glue, now because the little plastic part of the tape came off and the glue's left on, sticks to my pocket, it has an effect. So
Okay, so maybe not the best analogy.
So here's one of the things you said was pretty interesting to me was, I have a son that has cystic fibrosis, and for years the research has been around replacing the defective genes and the struggle behind doing that. And the research has gone a long ways to where we are today to improve the life expectancy of cystic fibrosis patients. One of the kicker to all of it, what we have not done yet, what have not been able to do, but we all believe and know that it's possible, it's close, is to be able to do what you were just talking about through inhalation, being able to absorb that molecular change that would then attach itself to those chromosomes and actually make that change to the delta F508 gene.
Mm-hmm.
But there's been tests, there've been studies, there've been things like that, but nothing has yet come all the way through yet. So we still are in this phase of we've always said this, is we have to help him maintain as long as he can maintain until the time comes when something like this is possible, because it is a 100% cure. It changes the defection and it makes it whole. So you can't reverse the damage up to that point, but you can fix that problem.
So the team I was working with gave a very bold prediction. And they said within the next 5 years, humans will be able to live on average over 100 years.
Wow, on average.
And they said that the first person who can be genetically manipulated to live forever was born around the turn of the century. That person's alive today. We don't know who it is yet. Now,
so
in conjunction, go ahead.
I just want to interject this because I'm curious, and I know there will be some of the listeners that will say this or think this. I don't know if you would call it morally, religiously, however you want to put that, biblically. There are things that if you're a Christian or if you're a believer that you read in the Bible that would tell you that's not possible in our lifetime just because of changing technology. How do you, I mean, I know a lot of scientists aren't Christians because of this. But what do you tell those people that are just, they don't believe it because, letter of the law, God's word, so to speak, says
God's word, 120 years, right?
126 years, I believe, is the max.
After Noah, right?
Right. So that I just find that interesting because the first thing that came to my mind when you said that, I'm fascinated by it, for one, because I'm a techie. Sure. And it would be amazing if that could happen.
But that's not even a complicated question, though, Kevin.
It is. It gets into the moral side of, or the biblical.
It does. But here's the thing. Look, logic. Just apply logic to it. Logic says true, right? So turn of the century, they genetically engineered somebody that can live forever, right? Theoretically, right? Whatever.
Yeah.
Or whatever. Well, that doesn't mean that they're bulletproof. That doesn't mean that they're not susceptible to other things that could impact them and limit their life expectancy. Those things still exist. And with all of life, there are so many additional variables that occur that are not within our control. That is the world that God has created. That is what it is, right? We don't control that. And that hasn't changed. So the fact that someone could live longer than what we thought might be possible, but it doesn't mean that they may not. I mean, anything can happen.
It is a fascinating concept. I mean, Dr. Carpenter said, on average, people will be living over 100. Yeah. That's already amazing in and of itself. Even if that were as good as we could get, that's probably 30 years higher than our average today, right?
What's the average today? Do we know what the average today is?
70, 75, maybe?
70. So in the States, 78 for men and 80, I think it's 83 for women.
Yeah. So just ask yourself that question. If 126 was the number, then someone obviously lived to 126 right. at some point.
Yeah.
Why are we not able to achieve that?
Oh, I firmly believe there's people alive today that don't live in the Western civilizations that is 126 and on their deathbed. But I do believe there are people living that age today.
Yeah, there was a French lady. She passed away, I want to say, in 1997, I think it was, something like that. Oldest living, 122 years, 164 days, I think.
Yeah, wow.
I mean, and she was a smoker until she was 117. And the doctor advised her to quit.
Yeah, George Burns lived to be 100. He was a cigar smoker. He smoked cigars all the time.
George Burns, right. And when they asked him what his doctor said about smoking cigars, he said, I don't know, he's dead.
Yeah, I outlived my doctor about 30 years. Yeah, that's pretty funny.
There's all kinds of, right now there was a recent project in DARPA where they were measuring biochronicity, and they were evaluating biochronicity, which is the ability of measuring the cell's life. And they were able to alter the life cycle of a single cell, by changing the length of the DNA.
Is that the telomere that they're?
Yeah, the telomeres, right. The telomeres at the end of the chromosomes, right, at the end of each strand of RNA.
I've heard about that. And
they just rebuilt the telomeres on the end, so that technically, as you cut down every time you split and double your money.
Yeah.
Right. They would add on more telomeres on the end, and that way it was an infinite loop. And basically, the cells never died. And as long as they were able to keep the mitochondria functioning at the level it needed to function, the cell would continue to live through the experiment. Some of them lasted 6 to 8 times longer than what they naturally would. So there is some interesting research out there right now that's going on. And one of the other things that DARPA was working on were these nanoparticles that are deployed in your body, again, run by, Billy Bob back there with a Windows 95 computer, but they were smart nanoparticles, and they had a mesh type of a network built inside the body. So basically, if you were stabbed, and this is for soldiers on the battlefield, if you were stabbed with a bayonet or something, and they pulled that out, those nanoparticles would rush to that area in the heart and form a seal over the heart so you didn't bleed out and die. And they would stay in place for about 72 hours before they lost power, because, they're all battery powered, right? Electromagnetically charged in different ways to run them. But they would last for 72 hours, which was enough to get you back to a critical care facility to have somebody operate on your heart and fix your heart. So
Wow.
there are these types of efforts that are in place right now that could help. But I say again, it's still run by Billy Bob and his Windows 95 system on the back end. That's still your weak point. Your human factor is still your weak point on all that stuff.
It just sounds more like, we had an episode a couple of months ago where our guest was pretty heavy in government contracts and was sharing that there's a lot that's going on within the government, but
Sure.
the government just does not have enough to really do the job that they need to do to ensure the best outcomes in the work that's happening. And so although those things are really exciting, it also creates a lot of concern around, okay, what are we not paying attention to that we need to pay attention to as this continues to move forward?
Yeah. So the interesting point about the government contract cycle, I was laughing when they were talking recently about how you can use Wi-Fi routers to identify somebody and stuff like that. And I'm thinking, like, my time at NSA, I was just like, oh yeah, when we were doing that, oh gosh, long time ago. So anything that you see today that's coming out in technology today happened in a government lab 10, 20, 30 years ago. Sorry, that's just the way it is.
Yeah.
So keep that in perspective too.
Yeah.
But the government, think of it like this. There's certain things that the government wants researched, right? And those are the things that they offer up money for and for contracts. And they'll have people do basic, advanced, applied scientific analysis to things to really bring those technologies forward. So being a deception guy, I would also put into the picture the reason the government's offering you that is because they don't want you to work on other stuff. They're not funding certain things on purpose because they don't want you to research that stuff.
Very intentional about it. Yeah.
That's exactly right. So that's why you have your approved technologies list. You have all of your focused funding authorizations and things of that nature, because they've defined what they want you to focus on and not what they don't want you to focus on, because there's no money to focus stuff on what they don't want you to look at.
Well, Dr. Carpenter, I want to jump into another topic on biohacking. I was watching your presentation, and it was entitled Protecting the Blueprint of Life. And it was fascinating. In that talk, you were talking about how very soon criminals and malicious actors are going to be able to hack our DNA. We kind of touched on it a little bit earlier, but you got into heavy details in your talk. And one of the things I remember from that is you were talking about a device you could purchase for $289 US to edit your own DNA at home. You can edit the DNA of your spouse, your dog, your plants, whatever. And You could even buy your own cryogenic chamber to put samples in. And they would even sell you a virus to inject into your DNA so that you could introduce that virus into your own body. And when you said that, my ears stood up and I'm like, what in the hell is going on here? So you got to talk about that. What ultimately is this going to mean to the human species if this is becoming commonplace? Where do you see this going? And are we finally getting to the point where when people say, hey, we're starting to play God way too much, we're going to be genetically building humans in labs soon? And I know what you're thinking because I heard you talk about that later too. So we got to get into this, man. This is cool stuff.
So yeah, being from Brooklyn, I immediately have a negative outlook on almost everything, even though I try to maintain a positive, cheery, sunny outlook on life. I know that humans are going to do the wrong thing inevitably because that's
absolutely
what we do.
It's in our nature, right?
Yeah.
Right. Look at the automobile. This is going to help people. We can do this and this. And now we have junkyards piled high with stuff. Oh, don't worry. Your refrigerator is going to be great. You have all this food that's spoiled. You're wasting all your food, right? Landfills. Oh my gosh. What are the aliens going to say about us about 3,000 years from now? Look at this. What, they got our whole story right there in the landfill.
Yeah.
Shoot. Archaeologists taught us how to do that stuff. So, but don't be afraid. So, because think of it this way, your next Tinder match might be Park Golden Retriever. You don't know it.
Oh, yay.
Or, maybe your neighbor's tulips are glowing at night for, some unknown reason or so.
So like
just somebody messing around, with the editing kit.
So like you get this, like say I got this and I did this at home. What would I do with editing my DNA?
Where can you, what kind of,
so I edited it.
Mad
now what am I going to do with it?
Craziness is going on here. Where are we going to take that?
Yeah.
So so interestingly enough, it's it's a DNA editing kit that you can get. It's got the CRISPR, and everything fits in a shoebox too. It's pretty neat. You get a DNA sample for editing, or you can get your own DNA if you'd like. But the virus is important because that's how it gets into your body. So there's only certain viruses that will go to where you want it to go in the body. Like we looked at doing long-term data storage in people, and we had a virus that we loaded the manipulated DNA into in the CRISPR system. And we put it right back here in the nail bed. Sorry about that. Let me take a different finger. We used the middle finger. I'm sorry. So we put it right here into the living cells in the back of the nail bed so that as the nail moved out and it keratinized, or as the nail died and became hard, right, that data was stored in the fingernail. So you have a long-term data storage for up to your fingernails about 3-4 months, your toenails about 6-7 months or so. And you can just take that data with you. Can you imagine a clandestine service?
Wow.
Like moving data in or out of somewhere? All you have to do is get a DNA kit dropped off at your flat or something like that. And boom, you've stolen all the Russian secrets in your fingernail.
Man.
And how do you take it? You take your fingernail clippers, you drop it off, and you leave it there, and somebody comes over and picks up your fingernail, and that's it. Nothing suspicious about that.
Oh, so somebody we talked about earlier today might even try that if he knew he could get his hands on one of those things.
So, but yeah, in reality, are we playing God? Wow, are we? We kind of are, because you don't need a PhD. You don't need no ethics board. There's no IRB approval. There's no oversight. There's nothing.
Yeah.
And the work that like the Wright brothers did in their garage, making an airplane that you can't do anymore because the government doesn't fund that type of research. There's no initiative like that to do research on your own. There's no incentive to do it. But you could go over here and create a virus that literally could wipe out all of humankind in your garage.
That's
with
what
no oversight.
That's immediately what came to mind when you said it. Is like, okay, if this is a mainstream shoebox home lab that you can buy for $300, take it home and just fiddle with viruses, who's to say that you couldn't create something that the world's never seen and make COVID look like a common cold. I mean, that's what scares me about it, is the fact that if this is really something that I can get my hands on, knowing as little as I know about what that's capable of doing, how much damage could I do with it?
Biomalware is a
Kevin,
reality.
you can't do any damage.
Well, I probably can't,
You don't know
Jason, just
enough.
because I wouldn't even.
I would worry about you.
Dude, I'm still the guy, and I was gonna say this earlier. I didn't say it, but I'm the guy that raises my hand and say, I still don't really understand blockchain. I'll be honest. It's way beyond me.
Fair is fair. Yeah. No, fair is fair. No, but I think about it. So you really do have biomalware, right? It is a reality. Encoding malicious code into the DNA is just inserting, and all you do is literally with the CRISPR system, you just type that stuff in, man. And it gets loaded into the DNA sequencing that's in the virus, and you can just get that into the person. You either inject it or they, inhale it.
How did the
Now the home kit, you just have to inject it, so you got to be kind of close,
how do the raw materials come about? How do you get the precise chemicals or biology needed to create a virus?
So the viruses, they just grow them in the lab and they include them in the kit. That's it.
Oh, man.
How about this, Kevin? You get sick with COVID, and then you cotton swab it up in your nose all the way back there,
Yeah,
and then you
got
put
that
it in the kit, and then you use it.
Yeah, I mean, I understand we all get exposed to certain common viruses every day, but if you buy the kit, can you say, "Hey, throw me in one of the secret viruses," or
Give me
throw
some
me
of that extra special nasty stuff.
give me a grab bag.
Yeah,
Surprise me.
Viruses. Nice.
Surprise me with the flavor of the week, man, because I want to do some crazy stuff.
Yeah, the vectors that they use that you introduce DNA into the body are basically pretty benign viruses. You won't get sick from them, anything like that. They're very, very, very low key. So it's lower than. So go back to the COVID thing for a second. There's 7 human coronaviruses that we know about, right? 4 of them cause the common cold, and 3 of them, since we started gain of function testing, have shown up, and that's SARS, MERS, and SARS-CoV-2. But only since we started gain of function testing. Now, I'm not going to say one way or another about what happened there, but I know that the first 4 are extremely benign, and they'll give you the common cold symptom. You'll look like you have the flu. You drink some water and you feel better. The latter 3, they would not be included in the kit. Let me put it that way.
Well, I'm kind of looking back on COVID. I knew several people that ended up getting very sick.
Yeah.
Several of my friends almost died. But then I look at all the numbers that they're saying, the deaths related to COVID. And if you believe what you hear or read in certain subsets of people, they would say all of those deaths weren't COVID. Many of the deaths that normally died from the flu and would have died from the flu that year weren't counted as flu deaths. They were counted as COVID deaths. I don't understand the reasoning behind any of that, but I do find it odd that so many people, supposedly millions of people, died from this coronavirus, that most of the people when they got it said, dude, it wasn't bad at all. I mean, I barely had a fever or whatever. I mean, is it just your own genetic biology that reacts differently? Or is it really just a weak ass virus and it got blown out of proportion?
So no, it was a moderate virus at best, I would say. So now you're leaning on the epidemiology side of my my world, which is fine, because I did do work for CDC looking at the research for COVID for 2 years. And I did look at the shots that were given, the effectiveness of the shots, all that other stuff. I did all that stuff for 2 years. And I would say that it was a moderate virus that keyed in, like viruses do, on certain factors. One was blood type. One was Rh factor. Those were key. SARS-CoV-2, I would say, was not a respiratory virus. It was a blood virus, which is extremely, if you want to talk everyday talk, that's fine. It's controversial. In epidemiology circles, we're all like, yep, absolutely, blood virus, because it keyed in on certain aspects of the hematologic functioning, or how the blood operates, and the different
Clotting,
components of
things
the
like
blood
that.
operate. Not a respiratory virus at all. So
So it would affect things like clotting or coagulation in the bloodstream, or what?
It what it did was it replaced oxygen in the blood cells. So basically, like when you get carbon monoxide poisoning, the carbon monoxide atoms have a stronger attachment to the red blood cells themselves, and basically they push the oxygen out, so you suffocate inside. The same thing happened here. These cells, these atoms, together, collectively, the molecules, would push out oxygen. Number one. Number two, it created such a buildup in the cilia inside of the lungs that there was a mucus that formed. So no matter how much oxygen you pumped into somebody on a respirator, basically you didn't do anything to them, because it was a mucus that pretty much encompassed all of the cilia where the oxygen flow happens, the alveoli, where the oxygen exchange happens into the lungs, it gets into your body.
Yeah.
So everybody who was on a respirator was actually, I'm sorry to say, they were killed by the respirator.
That's what you kept reading. Yeah.
They're aspirating on it.
Yeah.
Okay. Yeah. So we knew that like early on, and we were like waving the flag, telling people, you got to get off this stuff.
Yeah.
This isn't right. It's not a respiratory disease.
Wow.
Yeah.
Wild.
Crazy stuff, man. Crazy stuff. Well, guys, we've covered a lot at level 2. let's take a break, because we're gonna go even deeper in this last part.
So this gets crazier, you're saying, Jason?
Oh, it gets a little off the rails in this next part. So,
all right, let's do it. Let's take a break
right.
then. All right.
Do zero-day exploits and supply chain attacks keep you up at night? Worry no more. You can harden your security with ThreatLocker. Imagine taking a proactive, deny-by-default approach to cybersecurity, blocking every action, process, and user unless specifically authorized by your team. ThreatLocker helps you do this and provides a full audit of every action, allowed or blocked, for risk management and compliance. Onboarding and operation is fully supported by their US-based support team. Stop the exploitation of trusted applications within your organization to keep you running efficiently and secure, protected from ransomware. Worldwide, companies like JetBlue trust ThreatLocker to secure their data and keep their business operations flying high. To learn more about how ThreatLocker can mitigate unknown threats and ensure compliance for your organization, visit threatlocker.com.
wow. So we went from high level to, I wouldn't even say it was level 1 deep. It was like level 2 or 3 deep on this last segment. And now we're going to get into some serious crazy. So prepare yourself for what's coming. Here's where I want to start.
Let's go full off the rails, boys.
Yeah, it's going to get off the rails right now. So here's where I want to start. So Dr. Carpenter, I was listening to one of your presentations, and I was like so intrigued in where you were taking the conversation. There were many things that stood out to me, but 2 things I want to bring up. One, the South African study that showed that blood can stay viable in a mosquito for up to 3 days. And it made me think, how many times, look, I'm from Louisiana. So I've had my wars with mosquitoes plenty.
You've seen one or two?
Yeah. How many times has a mosquito landed on me and I'm like, and a big splatter of blood comes out? And I know that wasn't my blood because it just landed on me. And that's what it made me think of when you were saying that, like the magnitude of blood being viable and being transported by mosquitoes for up to 3 days anywhere. the implications of that, even from a biosecurity standpoint, the implications of that just like blew my mind as I started to think about it, right? A malicious hacker could really do a lot with, you didn't even have to be malicious hacker, right? You could just be a malicious individual, right? And you like want to commit a crime, and you have mosquito blood that you've collected, and you like, go in and like drop it all over the crime
Nation
scene.
state psychos with mosquito blood, man.
Whatever, right? But so that was one. And the second thing, going back to the CRISPR conversation and the home kit, the second thing really floored me. And it was that we have genetically engineered and brought back to life woolly mammoth meat, just to make meatballs with it to serve.
Yeah.
So tell us a little bit about that craziness.
Sure. So, we'll start with the mosquitoes first. Basically, there's some very interesting research that showed that mosquitoes will retain human blood for up to 3 days. You can get DNA out of it for up to 3 days after you've been bitten.
Wow.
Which is great. Like you said, if you took that and genetically duplicated that, you could create a crime scene. Wouldn't take much effort at all, to be very honest. I want to say it was 1951 or 1953, the U.S. government did a test on the people of Savannah, Georgia. It's called Operation Big Bite. And what they did was they released, it was the CIA and the U.S. Army, I think it was a chemical corps or signal corps or something. And they had released hundreds of thousands of mosquitoes into Savannah to identify the distribution pattern and who bit whom, or who bit whom, something like that, who was bit, and the timestamp between bites, along with the growth of the colony after that.
Wow.
And it was just one of several hundred human tests done on the U.S. population, that we didn't get told about until the 90s. That they had done that, like the strontium-134 overlay throughout the midsection of the country. You can see like cancer in kids 6th to 12th grade, and the strontium-134 overlay. It's like the same thing.
Yeah.
It's like, holy cow. But in this case, the mosquitoes were used to spread a disease. And basically, it was a benign disease, we were told. At the time, we believed it was a benign disease. Sorry. We've come to learn that it was not necessarily a benign disease. And a lot of people at the time had gotten sick. And the CIA had taken their people and put them in the emergency rooms of the hospitals and in pop-up public health tents. So they were doing the same thing to us, which was interesting that they've done to other countries, to measure how mosquitoes move and how they're distributed. When you take that and the ability to actually collect usable information, you could release mosquitoes into a population where you have a target. You got a target package on someone. You know this guy. You want him. And you send mosquitoes in there, and X number are going to bite that guy, and you'll be able to collect all the DNA evidence you want from that guy.
Wow. Yeah, that is interesting. That would be an interesting take. You'd
It's
have
like
to
drone
be a
warfare with
savant at
insects.
collecting mosquitoes, though. But
Yeah, China built a fly that it's about this big, and it has a needle, a hypodermic on the front of it, has IR lenses over the eyes, and it has a sensor, and it connects through Wi-Fi. And basically, they would send them out to the field, and what they were looking for were cows infected with mad cow disease. And with the IR sensors on the eyes, they would identify the cows by temperature. And if a cow had elevated temperature, They would go down, hit it with the hypodermic, take the sample, and then return to base.
Wow.
So
now,
there's a lot of
who's controlling these things? How did they get
Billy
back?
Bob in a Windows 95 box.
Billy Bob is.
It's the
Billy
same
Bob back
thing
there,
every
Kevin.
time, man. I'm telling you.
Billy Bob and his Windows 95
That's
is
all he needs
dangerous,
is Windows
man.
95.
Look
That's
at
insane.
people running, the MRIs in hospitals. What do they have? XP.
Yeah,
Right?
Yeah.
they
Okay.
do.
They got to still wait 3 days to get the results, but
I saw an EKG running on 361. NT. It's like,
Yeah.
you gotta be kidding me.
I know.
It's amazing, guys, that some of the biggest hacks that resulted in human death haven't been related to that right there. And I know it's not, because the medical industry is doing a fantastic freaking bang up job protecting their old crappy devices, their OT device. That's not what's preventing that from happening.
Now,
It's amazing.
when I was in government, we used to have a saying, security through obsolescence. And basically, it was so old. I used to provide security to the nuclear command and control systems back in the day, and they had these mainframes. It's like, how are you going to hack a mainframe? Punch cards, for God's sakes,
Yeah.
How do you hack that? You get somebody in there with the little,
punch cards, yeah.
So
the hacker
second
gets in there
question-
like, I don't even want to mess with this.
What am I
man.
going to do with this? Yeah, you can't do anything with this.
All your admins in there working on it are like 87 years old, but they're the only ones that know anything about it.
So, true story, out of the nuclear enterprise, there was a group of guys. There were 3 guys. They were the only guys for certain applications that would do all of the updates. And they were the guys that had been doing the updates for 35 years.
Oh, man.
Yeah.
That's
These guys are doing updates on what? On COBOL.
Oh, I
learned
started
that
my
back,
career writing COBOL.
I learned Fortran 4.
Yeah.
I was a youngin' back in the day with the old stuff like that. These guys are still updating COBOL. They haven't updated anything, because you have to be careful. You don't want to mess that stuff up.
Yeah.
You mess it up, you get it's bad
Yeah.
news. But so anyway, so the second question about the woolly mammoth meatballs was extremely interesting. This was bioethics off the cart, off the tracks, basically. The group in New Zealand, I want to say they were the Vow company. I think it was Vow or something like that. They basically took DNA from the mammoth that was frozen, and it was reconstituted myoglobin. And you know what myoglobin is? When you get a really nice steak, right? And you get all the blood running off of it and stuff. And I'm the guy who sits there and says, it's not blood. That's myoglobin.
Yeah.
Doggone it. There's no blood in that thing. Stop that.
Yeah.
So that's my job at the house. But myoglobin, the stuff that enables oxygen to bind, right, to red blood cells, is the stuff that they found the DNA in, and it was incomplete. So what they did was they took African elephants' DNA, and they completed the sequence with that, and they grew the meat in the lab in the same way that, they've been growing meat in Japan, and they're doing it here now and in Europe and stuff like that. And they're growing the meat in the lab. They did this with the woolly mammoth, and to honor the animal that went extinct, they created meatballs so we could eat the meatballs of woolly mammoth. And that it didn't seem like a great idea. Yeah, they took the gene and they put it into a sheep stem cell so it would grow. That's how they did it. But again, the IT control system on this thing, you'll be impressed. These guys, because I talked to them, and they used Windows ME. Now, I don't know of anybody on planet Earth other than these guys who are still using Windows ME.
What happened to end of life? People don't get the notice.
Yeah, for Windows ME, end of life was like 2 weeks after it hit the market.
I know.
That's true security by obsolescence there.
Yeah, I never thought I'd see this. How do you hack Windows ME? I don't know. You turn it on?
I don't even know that I've ever installed ME ever in my life.
No, I'm sure I played around with it at some point, but at some point that would have been, to your point, would have been a short-lived experience, because immediately, at worst, I would have gotten updates to update it and upgrade it to the next thing, right? So these people had to have just continuously ignore all of that.
Yeah, because it was a closed system that they were working with. They said, Windows ME is fine.
Yeah, sure.
And I'm just sitting here thinking, like, okay, I do TSCM sweeps and stuff like that, like all the time. I love doing that RF stuff. And I know that I can shoot a signal through a wall and I can hit your router. And if I can do that inside of your closed system, then maybe you don't have meatballs.
Yeah.
Maybe you have something else. Maybe you have guacamole or something.
Yeah. Yeah.
But worst case scenario, you don't sell anything and you go bankrupt, I guess.
Sure. Yes.
So basically what I'm hearing here is that the whole premise behind Jurassic Park is not too far-fetched.
No, what was that animal they just brought back? They just brought something back from extinction.
Yeah, it was a
Arctic wolf or something.
Yeah, a white wolf of
white
some
wolf.
sort.
Yeah,
dire wolf.
Yeah, the doggone thing's been extinct for only 10,000 years. Not bad.
Yeah. Yeah. But, right.
Okay. Wait a minute. There's a reason why he went extinct in the first place, right?
Yeah.
And there are literally a dozen movies that say this is a bad idea.
Oh yeah. Yeah.
Yeah. So let's do it.
Well, you would think the ones that are just now going extinct, they could bring back pretty simply then, because we've seen these animals alive in our lifetime. We have the real DNA from those things. We don't even have to mix it with too much.
Yeah. Yeah. I mean, so there is, in 1917, there was a passenger pigeon. Her name was Cherami. And she was a pigeon used for messages during World War I by the U.S. Army. And she was part of the 77th Infantry Division from New York that went to fight in France. And in the Meuse, Oregon campaign, she was sent out to go bring a message back to the division headquarters to let them know that they were dropping their artillery on our people. And she got shot about 6 or 7 times.
Oh gosh.
And she lost a leg and stuff, but she got the message back and they ceased the artillery barrage. And these guys lasted 3 days behind German lines. I mean, they had flamethrowers, they bombed them, they grenade everything. These guys didn't give up. They said they were a bunch of New York gangsters and punks. And in fact, it was the New York hodgepodge, right? But this pigeon that survived is in the Smithsonian Institute.
What?
So you actually have retrievable DNA from an actual passenger pigeon in the Smithsonian in an environmentally controlled device. You really could bring back the passenger pigeon.
Wow.
Why we'd want more pigeons, I don't know, but I have enough pigeons now everywhere.
Yeah.
It'd be like bringing back the Canadian goose. Nobody wants that.
Dude, that's crazy. Well, I was just thinking that because we just lost the last white rhino. We might as well just bring that thing back too. We got the capability to do it. It's true. These things, they go extinct for a reason, but I think a lot of it, when it's man-made reasons, we should probably use man-made means to bring them back if we have the capability. That. Yeah, absolutely.
Oh, absolutely. If we screwed that up, we need to fix it.
Yeah.
If we have the capability to do that, we should absolutely fix things.
Yeah, for sure.
I see aliens flying by here, and and you've seen that thing, and they roll up their windows when they come past here, like, I don't want any part of this.
Yeah, these people are crazy.
They're nuts. Yeah.
Well, all right, guys, we got to get into two more topics here before we wrap it up. And the first one, this is where we really get off the rails. So
off the rails,
literally off the rail. This is insanity. So my goodness, I almost jumped out of my chair when you said this in your discussion, and we were talking about more things that you can do with the DNA through the CRISPR systems and the systems that manipulate the DNA. But I never thought this would come out of your mouth when you were talking about injecting DNA from one source into another source intentionally so that you could create synthetic dreams into these people as they slept. And so before we wrap up for the night, we definitely need to touch on this. And my question to this, and I'm being serious when I ask this, is as stupid as this is going to sound. If we can create synthetic dreams and visions using this DNA manipulation and injections, do you believe we could possibly create a zombie apocalypse with this technology?
So it is kind of as wild as it sounds.
It is wild
if you think about it. But it also it's totally real. Cutting edge research is progressing quietly in neurobiology, epigenetics, synthetic biology labs. It's happening right now. The idea that dream manipulation through DNA-based intervention, it's not science fiction. Scientists have begun exploring like the intercellular signaling mechanisms, particularly neuropeptide encoding with DNA plasmids, and that influences neurotransmitter expression in brainwave modulation. And what that really means is you're using chemicals in the DNA is expressed in a certain way to give a certain result. And it's pushed along the nervous system. So your nervous system is electrical and chemical. It's injected into the chemical portion, and the genes are expressed a certain way. And then the nervous system carries that message and puts the movie up on the screen for you. And you watch that movie. And that's kind of what happens. So you can influence things like REM sleeping. Think about it. You know, you can induce a deep delta wave sleep if you wanted to. I mean, there's all kinds of
these are good things though. I mean, if you can inject the same apparition into someone's dreams, you can also freak them out with, you know, Freddy Krueger from Nightmare on Elm Street, right?
Right. So memory, perception, moral inclination could be filtered into your dreams. You know, you're not off base with the zombie question, to be honest with you.
Well, that's why I asked, because as soon as you said this in your talk, I'm like, okay, I'm asking this question.
Yeah. If you combine dream manipulation with behavioral rewrites from CRISPR, like limbic system hijacking, you really could have a zombie situation. I think it would be more biologically controllable humans. I think that's more of what it would be: emotionally flattened, neurologically synced, and psychogenetically programmed.
I'm not really thinking that it's dead people that reanimate and start eating brains, but what I'm envisioning.
On the other hand, you could enable reanimation.
Could you?
At this point,
could you?
Technically, you could. We've done it with rabbits, and we've done it with rats.
No way.
Technically, you can, and that's an injection of DNA that's been genetically manipulated to actually bring life back. Cells don't necessarily die when you die immediately. It takes time. And some cells continue on for a while after you're dead. Just because the macro system is expired doesn't mean the micro system's got that message yet.
So your organs can shut down, but because the micro system is still running underneath, if you can inject the symbol into those microsystems to say, hey, you're not dead yet.
Right. You can actually, there's some interesting research that came out, I want to say last year, that when a person decides that they no longer want to live, a chemical message is sent through the body to let the organs know that it's time to shut down. And the organs are hit first, as opposed to like interstitial tissue or like small things in between, like this, like, you know, the skin is an organ, right? But underneath that, there's cells, and there's fluid. Well, not everything gets that message at the same time. So,
Right.
and not everything gets that message at the same magnitude. So technically, there are cells in the body that are still alive, even after you clinically been, declared dead.
That explains why certain muscles can still be alive and movements and things like that. When you're really your organs have shut down, but your arm might twitch or something when you're in a funeral home.
It would be no more than a message to do something, but with no intent or meaning.
Yeah.
Right.
Yeah.
And that's why certain politicians can stay in office forever too,
Yeah, right. Well, but that brings up a thought as you were saying this. Think about this. Like this, what we're talking about with injecting interpretations into your dreams.
Limbic hijacking.
Yeah,
What it would be.
You could go to bed one night a Democrat, wake up a Republican, or vice versa.
Right. Right. You philosophically could have a complete change in who
That's
you
wild.
believe you are, your moral inclination.
Someone can inject through an aerosol into your house.
That's
all
the
this
key.
stuff.
You got to make it airborne to make it.
And then all of a sudden,
and you can. So we did a research project a number of years ago, and basically we did do an aerosol release with nanoparticles. And this is, I forget which of my presentations I shared this in, but basically we took a bunch of subjects and we did an MRI of them. We created a complete matrix of them. We had different groups of nanoparticles and we programmed those. Some were nano carriers, some were signal boosters, like retrans type stuff. And then others were I forgot the word. Anyway, they build together and they'll create new things inside the body. And we took these nanoparticles and we aerosoled them into a room and people would breathe them in. And because of body temperature, pH, they would go to a certain spot in the body. And there was another dozen variables or so that we used to program all of these. And what we were able to do was create in the back of the right hand an array where we could connect Bluetooth 4.0.
What?
To tell you how long ago this was. The nanoparticles went into the second level of the skin surface. They were basically on the surface of the skin. And you could directly connect Bluetooth to it.
No way.
From there, we took and we ran the signal up the median nerve. Median nerve controls these four fingers here. Okay. On the major branch of the median nerve, and we spaced out the nanoparticles to transmit and retrans that signal running off of the electricity in the nervous system. And we sent it up this arm and we shot it down this arm. And in the left arm, we sent off the nano carriers. And they were all in one finger. This time we did choose this finger again, by the way. Okay. And what we had in the nano carriers was acetylcholine and acetylcholine esterase, the neurotransmitter and the enzyme that neutralizes it. And what we were able to do with that is send the signal, connect, send a message up, and you're able to paralyze that finger. So you ended up with this, as he tries to send the hand, you just get that until you send the next message that releases the enzyme that neutralizes the acetylcholine, and you can bend the finger again. So this has been done like that. So this was important research, especially for people that have Parkinson's. Uncontrollable shaking is an imbalance in acetylcholine and acetylcholine esterase, as well as another dozen things or so. But this was something to show that we could actually control that in the body. It also was very promising in the situation if you had a shooter, an active shooter, right?
Interesting.
Couldn't pull the trigger.
Yeah.
Yeah.
You'd immediately stop them.
Wow.
Wow.
Well, I got a sidebar, Jason. I'm sorry. I know we need to get to the education village. We will. I got
You
one
always
question.
do this, Kevin. You always do this.
I know, but this is something that I just hit me a minute ago, and I got to
42.
ask Dr. Carpenter because he's going to know. We hear this all the time. There's many people who have already proven they can cure cancer. There's many cures out there, supposedly, that are being held back for whatever reasons, FDA, whatever, can't get approved. Is the cure to cancer being held back from humans because of the big pharma industry and the money they're making on cancer?
Yes.
So that's actually a great question. And it's a little more complicated than yes, because it's a little more complicated than big pharma. The short answer is yes.
That's the short answer. I knew it was going to be yes.
Short answer. The full answer comes out of the insurance industry that creates processes and says that you have to have a health maintenance plan now instead of going to the doctor and getting medical treatment. You have a health plan now. So their motto is a patient cured is a patient lost.
Yeah.
Yes.
So that's why you can't go in and get medical treatment anymore, just like that. You have to go in, you have to go to your primary care who manages your care, who sends it forward to a specialist who sends you over for a referral for here or there. Then you have to get approval. You can't go in and have surgery. You have to go through the protocols,
Yeah, you have to have all the tests. You have to spend all the preliminary money.
Are your fingernails clean? Did he comb his hair this morning? Yes. Okay, he can have surgery, right? It's literally like that. And that is the reimbursement model, because the money that's reimbursed through CMS, the Centers for Medicaid and Medicare Services, they coordinate, manage all reimbursements for insurance companies, not just Medicaid and Medicare. So their reimbursement rates table requires all of these steps in between. And it's built in a way to ensure that there would be positive cash flow for everybody involved.
That's so backward ass. That's so messed up.
Yeah.
Yeah. But that's kind of how it works. It's even more. We could do a 17.2 hour discussion on how CMS does reimbursements one day, but that's the high level picture of how it's laid out.
Yeah.
Basically,
Wow.
It's titrated in a certain way so that X number of people get X amount of money. And
almost like a freaking Ponzi scheme.
I mean, look at this. At the end of the day, if you were suffering from cancer and you had no other alternative, and it was pretty early in your life cycle of fighting it, with the technology we have with things like CRISPR, do you really think that we couldn't just alter DNA and just modify it so you don't have it?
No, I honestly believe that you can. And it annoys me that we for whatever reason politically that we don't. That's why I asked the question, because I do believe we do have the cure.
So each cancer is a little bit different.
Yeah.
Each requires a little bit different specialized attention to it. My impression was, at the end of the day, if you can identify a cancer cell, and you can identify cancer cells by the surface proteins, right? That's how you can tell a cancer cell from a healthy cell, basically. If you can identify like that, then you can launch a nanoparticle with a binding agent that actually links only to that type of a cell because it's attracted to the surface protein. Mm-hmm. And you could have it, raise its temperature or blow up, anything to affect or set off at certain, megahertz, whatever frequency that would be resonance frequency for that type of a cell. And you could literally have that cell blow up in the body and it would be gone.
Do you believe in autophagy and the power of the body to heal itself through eating the bad cells up just by fasting and things like that?
Yeah. So there is good evidence that is actually very effective. And to that point, there's also a lot of evidence. There's a recent study from NASA that came out that actually identified how you can use different tones to regenerate
yes.
DNA.
I've heard
and
that.
how you can actually fix mitochondria in your body. I think the 243 hertz is the micro.
You're talking the sound wave therapy. Yeah, that's crazy.
It wasn't supposed to be released. Funny enough, that's one
really?
That's one of those research areas that we were told not to look at, right? Because there's no money for research in that.
Mm-hmm. Yeah, yeah. That's another patient
I gotta
loss.
write that one down. Make sure I got that one down.
Yeah, the CIA studied that back during MK Ultra, right? They were doing all that work with different strange things, and those were some of the things in the Stargate program. And there was another Army program, Grill Flame. That was a Grill Flame, Grille, Grill Flame, and that's the Men That Stare at Goats. Those guys. That was all those types of programs, and they studied how different tones affect the body, different frequencies affect the body, because your body, everything operates at a specific frequency, right? And your body overall operates, so it makes sense that frequencies would affect your body. And Tesla, said, hey, the perfection is it's all in frequencies, right? 369 is perfect. Guess what? The perfect frequency for a body for harmony is 963 hertz, called the God frequency.
Yeah,
Tesla found that one out.
Yeah, I've seen that, and there's some YouTube videos out there. Anybody that's into this kind of stuff here that we're talking about, go out to YouTube and research it. There's lots of videos on this, and there's lots of people that believe that this stuff is powerful, very powerful.
Sure.
All right, Kevin, let's move on.
All right, I'm sorry, man. We got to move on. I want to get to this other last piece.
Dr. Carpenter, let's talk a little bit about the most exciting week of the year, the DEF CON events that are happening, and you have something special that you're launching this year, a village at DEF CON called the Education Village. You want to tell us a little bit about that?
Yeah, sure. We just found out about a week ago that it's either going to be the education community or the education village. We don't have a final on that yet. It seems that we're waiting on Jeff to tell us what he wants it to be. Either way, it's going to be, a limited engagement for the first year, like any village or community like that. But we're focusing on three key areas. First is a train the trainer type of a model, where we train people to be educators, mentors, and of people who are learning about IT. The second group is we want to emphasize on teaching how to teach and teach kids before the age of 8. And the age of 8 is an extremely critical point in a kid's life. That's when, before 8 years old, they can learn a second language like that. They can do anything, and they're a sponge. Then once you hit 8 years old, your brain changes gears. It grows differently and then starts to learn differently. So you're stuck in a different learning model, which is why adult learners learn differently than children do. At 8 years old, it's a perfect age. So if I want to teach a kid a new language, why am I not teaching them Python? Why am I not teaching them? Why am I not teaching them C+ or COBOL? Or anything.
Or how to work in a mainframe.
If you teach, if you teach them those languages, those kids will be fluent. They're going to be coders, like they're going to write stuff like you've never seen. But how do you teach an 8-year-old all that cool stuff? And those are the types of things that we're going to be talking about. And of course, the last part, the third part, is the adult learning aspect of it. People that are retraining, or we cater to people that would be professionals, parents, people that are just new to the industry, that are interested in learning about, helping them get into what hacking really is and what it's all about. And it's not just to be, about hacking. Of course, it would be all different types of IT engagement for them, but how they could also find their sweet spot, where they could learn to say, I'm good at this, or, how they would learn to say, I'm good at this, or I'm good at that, because they'll have no idea coming into it now. So it'd be basically to try to help guide them into what they would be really good at, what they would like to do.
Yeah, because there's a lot of directions you could go in the world of IT and cybersecurity too, and not everything's for everybody. So there's
Sure.
you can almost tailor their personalities to the direction in which you want to send them.
That's
I
right.
think
And
there's a lot to that.
cybersecurity is very much like medicine or law, in that you have specific groups of people. Defense. Well, in defense, how many different ways can you go? I can go a million different ways in defense. And I can just start with hardware and software, right? And just from those two groups to just go everywhere. And you have a million different sub-disciplines. And not everybody is good at every sub-discipline. And it's the same thing in medicine or in law. But I think that just to actually bring all this together, in the education aspect of it, to have people be aware of where they could be good at, and then focus in on that, is a service to them and would help them perform better, so they can give back to the community more. It's not this positive feedback loop that we have our CISOs in, where you're stressing them out to the point where something goes wrong and breaks. Why did they go wrong and break? Because you stressed them out. So, and then you fire them because of that. And then you need another CISO, and then you stress them out. And well, they're stressed out and something breaks. It's the same stupid loop that we've created ourselves.
Yeah.
And we don't want to see that happen anymore. So we figured, we've been given the opportunity to put together an educational aspect for teaching how to teach. We'll give it a shot and see if we can help some folks out.
Wow. Sounds exciting. Sounds like there's a lot of really cool things to expect at DEF CON this year. I'm looking forward to learning more about that and maybe attending the village and checking it out when we're there.
Stop on in.
With that, guys, I think we're coming to the end of this episode, and this has been an action-packed, a lot of information.
Man,
I think anyone listening to this one or watching is going to walk away thinking, oh, man, I got to go research some of this stuff, man. This was a lot of really cool information. So thank you for being on tonight, Dr. Carpenter. We really appreciated you being able to make time to be on our show tonight. It was a great conversation. I had a lot of fun. I enjoyed it a lot.
Thank you very much for having me, guys.
Yeah, thank you, Dr. Carpenter. And the last thing is where can people find you if they want to link up with you online anywhere?
So you can find me on LinkedIn. I'm there. If you want any of the research material or anything, you can just send me an email, and I'll be more than happy to just forward over whatever it is you're asking. Everything from the NASA study to anything else. It's just gcarpenter at WOCSA, WOCSA.org. And
awesome.
I'll get whatever you need back to you.
Perfect.
Awesome. Well, thank you for that. And guys, it's been fantastic. And I can't wait to release this one. This one's one that we're going to drop as soon as we can. I'm hoping to get this episode out early next week. So watch me work. It's dependent on this guy to get me my audio. That's why I said that. No pressure, Jason. Today is April 24th.
Get to work. Get to work.
All right. Everybody, cheers. We'll see you on the next one, guys.
See ya.
Take care.
Thank you for watching our latest episode of the Cyber Distortion Podcast. We only grow with your support. The best thing you can do to help us grow is to subscribe to our podcast on YouTube, follow us on X, and tell just one friend about the show. You can find out more about us on the blog site at www.cyberdistortion.com. Our X handle is @DistortionCyber, and you can also listen to our audio-only versions of the episodes on most major streaming podcast platforms. Just search for Cyber Distortion Podcast. Until next time, take care. Cheers.